This video is about determining the equation of a parabola from 3 data points using CAS. So we'll go to a spreadsheet and tag it with a name X for that column and Y for that column, and we'll enter in some data points, maybe a mix of smallish and biggish numbers. Okay, so those are the X values, the corresponding Y values. Let's make some numbers up here. Well, maybe 16.375, something like that. So there we have our set of numbers, 3 ordered pairs. There is the first ordered pair, second ordered pair, and third ordered pair. And just in here, we'll place the results of a quadratic fit. So we go to statistics, stat calculations, and then down to quadratic regression. Just hit that. Now up here it asks for the X list. That's the first column numbers. So they will be our X's. The name we gave to the Y numbers in column B was Y. We want to save the equation to equation with the name F1. Now there's a list of other possible options. You can call them anything you like, but F1 will be fine. The frequency list, we won't worry about that. We'll just leave it at 1. And then here we want to place our results in column C, not D. I choose C because it's closer to column B, and so we don't have to scroll across the screen to see the results. So we'll just hit OK. It places the title, quadratic, regression equation there. That's the ax squared plus bx plus c, and then the coefficients a, b and c. As you can see, you don't have to really scroll across the page to see what the coefficients are. Now we want to graph that to see what it looks like. So we'll go up to Home, choose Graph. Now remember we called the equation F1, so we just need to type in F1 only there, and that gives us the graph. Now we'll have to maneuver our way around this bit, so I've just grabbed it just to see where things are, and I'm going to go to Window, and I could use Zoom Fit. It doesn't give me a great deal of joy, so I'm going to choose Zoom Out, and just may need to use that a couple of times. And there we are. So I've just used Zoom Out with the center, moving the center around different places so I can get a picture of it. Now notice the icon up here tells it we're still in zoom mode, so to get out of that we go to Escape. And I'll just drag it up the screen a bit, and there is our graph. From there we can recover such things as the coordinates of the maximum turning point. There it is, correct to that number of decimal places. We might want the axial intercepts, so we go to Analyze Graph 0 and choose that one. So there's the first one. We'll do it again. 0. And there's the other one. Now supposing we wanted to find the points of intersection of that parabola and some given line. So we'll type in a mystery line saying 0.15 times x minus maybe 220. That'll do. And we can't see it, of course, so we have to drag our screen up and maybe zoom out again so we can see it. We'll make our center about there. There we go. Good position. Back to menu, Analyze Graph, Intersection. There is our first point. and its coordinates. And then we need a second point over to here, and we see its coordinates. And that's basically the job done. Now, had we decided to use simultaneous equations to find our regression coefficients A, B and C, we would have ended up with the same results by solving in the solve mode in an algebra window. Problem is with that is that it's a bit messy. This is a much more, well, I suppose, elegant way of handling the whole problem. So good luck with that. You might like to try one yourself.